We're going to continue our discussion of logic by defining two additional terms. We're going to look at what it means for statements to be logically equivalent and what it means for statements to be negations of each other. So logically equivalent means that we have two statements that share the same truth value in every case. And negations means that the two statements share opposite truth value in every case. So we're going to look at an example of each. So we'll begin here. In this problem, we have two statements. Our first statement is the negation of P and Q. And our second statement is the negation of P, then the negation of Q. So we're going to build a truth table for each of these two statements. So remember that anytime you're working with a compound statement that has a P and a Q, that you're going to begin with a P column that has two trues and two false values. And a Q column that alternates between true and false. So looking at our first statement, looking at the left side of the statement, I see that I need a negation of P, which I do not currently have in my table. So that's going to be the first thing that I'm going to do. Remember, the negation of P is simply found by taking the P column and looking at the opposite truth values. So instead of true and true to begin, you're going to go false and false. And instead of false and false, we're going to go true and true. And so in doing that, we have taken care of the left side of the statement. The right side of the statement is already done because I have a Q column right here. Once I have completed the left side and the right side of the statement, I'm going to then put the statement together and look at the truth value of the combined statement. So remember that we begin by doing a little copying. So under the negation of P, we're going to copy the values that we came up with in that column. So F, F, T, T. We're then going to add our symbol, so we'll do the and symbol. And then we're going to copy the Q values. So we'll copy TF, TF. And then what we want to do is use our rules to determine the truth value for each of these final four statements. So these are AND statements, so we'll be using the AND chart. False and true, that's this one, and it's equal to false. False and false, also equal to false. True and true is equal to true. And true and false is equal to false. Remember that your answer to a truth table is the final column on the chart. Okay, so that takes care of our first statement. Let's go ahead and look at the second one. So on the second statement, beginning on the left side, I see that I need a negation of P that I do not yet have in the chart. So we'll go ahead and do a negation of P by taking the opposite of the P values. So false, false, true, true. That will take care of the left side of that compound statement. Now look at the right side. The right side has a negation of Q. I don't have that column either, so I'm going to go ahead and add that one. And that will be found by taking the opposite of these values. So instead of true, false, we'll go false, true, true. And that will take care of the right side. Once that's done, we have the left side done and the right side done. We're ready to put them together into our final column. So we'll begin by copying the negation of p-values underneath this not p. So F, F, T, T. We'll put our symbol in, which is the arrow in this case. And then we'll copy the negation of q values. So F, T, F, T. Then we'll use our if-then chart to determine the truth value for each of these four statements. So F, then F is true. F arrow T is also true. T arrow F is false. And T arrow T is true. And again, the final answers to a truth table are those answers in the last column. So now what we want to do is we want to compare the two red columns between the two statements. And if you notice, they're exactly opposite of each other. This one begins false, false. This one begins true, true. The third value in the left in this one is a true. The third value over here is a false. The last value is a false. The last value is a true. So what I'm seeing between the two problems is that they are exactly opposite in every case. So this is an example of a negation. A negation, remember, two statements that share the opposite truth value in every case. So these are negations. All right, let's look at one additional example. We're going to do the same thing here. We have two problems. We have we have P, if and only if Q, and we have the second compound statement. And we're going to build a truth table for each one. Each of them has a P and a Q, so I know that the setup will be the same for each one. The P values will be two trues and two false values. And the Q values will alternate true, false, true, false. So on statement number 1, if I look at the left side just has a P, and I already have a P column, so the left side is done. The right side has only a Q, and I already have a Q column, so the right side is done. So the only thing that is left on problem number 1 is for me to put these two together. So I'm going to do in my final column P, if and only if, Q. And we're going to begin by copying. So underneath the P, we're going to copy these values. So T, T, F, F. I'm going to put my double arrow and then I'm going to copy the Q values. So TF, TF. Then we're going to use our chart to determine our answers. Now this is an if and only if, and I don't have the if and only if chart right handy here, so I'm going to go back and let you take a quick look at it. All right, so our if and only if chart is right here. Remember that on the if and only if chart, that these are true if you have the same two statements, the same two truth values on the left side. So the ones that are true are the true, and then the false and false. All right, so I'm going to keep that in mind. I'm going to go back to my problem, and I'm going to fill in those answers. So that would mean that this one is true, and this one is true. That's the TT and the FF. The other two, since it has one of each, would be false. So our final answers for problem number 1 are right here. All right, we'll now look at problem number 2. So on problem number 2, as we look at building the left-hand side, I notice that I have a P column, I have a Q column, but I don't have a column where I have the if-then arrow in between. So that's going to be the first thing that I'm going to do. I'm going to start by copying. So underneath the P, I'm going to copy the P values. So T, T, F, F. I'm going to put my arrow. And then underneath the Q, I'm going to copy the Q values. So TF, TF. And then I'm going to use my chart to look up the answers. So T arrow T is true. T arrow F is false. F arrow T is true. And F arrow F is true. So we've now completed the left side of the problem. So let's go ahead now and take a look at the right side. I have a Q column, I have a P column, so that part is done. What I don't have is a Q arrow P column. So let's go ahead and add that. So underneath the Q, I'm going to copy the Q values. So TF, TF. Just draw a line right here so I don't get confused. All right, now I'm going to do the arrow. And I'm going to copy the P values. So TTFF. Now we're going to look at our chart and write the answers down. So T arrow T is true. F arrow T is true. T arrow F is false. F arrow F is true. So that completes the right-hand side of the compound statement. Now that the left side is done and the right side is done, I now need to do both parts together. So I'm going to do P arrow Q and Q arrow P. So again, we're going to copy. So P arrow Q, that is going to be these answers that we came up with right here. So I'm going to copy those over. T, F, T, T. We're going to then do our AND symbol. And then I'm going to do Q arrow P. So that's going to be these answers. So true, true, false, true. Now we'll find the solutions for these. So these are our and statements. And I have the chart here in case we need it. So true and true is true. False and true is false. True and false is false. And true is true. Here is the final answer for our second problem. So when I make a comparison between the two problems, I see that my answers are exactly the same. TFFT in the first case, TFFT in the second case. So this is an example of one that is logically equivalent. Logically equivalent means that the statements share the same truth value. They're exactly the same in every case. So I can write that these two are logically equivalent. So again, if your answers are exactly opposite, they are negations. If your answers are logically equivalent, that means that they are exactly the same in every case.